So today we will be seeing how to generate number, or should I say number of subsequence of a given array. I will just write it down. So what we will be given, the first and foremost is the question. The question is generate all the subsequence. I have a follow-up question on this, but that in turn will be solved via this route only. Generate all the subsequence of the given array. Okay. So let's see how this question will be done and what the question really states and what do we mean by subsequence. So first and foremost, let's say we are given with an array 1, 3, 5, 2, 8. Okay, let us not take a very big one, but yeah, let us say that we are given with the following array. What do I mean by subsequence? So I'll just write it and I think you will get it. If I just put it down, 1 is a subsequence of this array, 1 comma 3 is a subsequence of this array, 1 comma 2 comma 8 is also a subsequence of this array. Similarly, 5 comma 8 is also a subsequence of this array, and so on. Okay, you get the point. All the possible permutations of subarrays that you can, no, not subarrays, all the permutations of subsequent arrays that you can form. So these are what should I say, subsequent arrays that you can form. Okay, this part is, I think, clear. Now the method that we will be talking about today is purely recursive. Okay, how will we be approaching this problem in a recursive fashion, that also we will see. And there is a general pattern that will help us in the upcoming problem statements for recursion. That general pattern, should I say, is the take and not take pattern. Take and not take pattern. This pattern will help us in most of the recursive problems. Okay, so let us straight away go on to the dry run, because I think dry run is the most beneficial thing for any person. It gets us to know the algorithm better and the problem statement also becomes very clear. So I'll just straight away start doing the question, and I think after certain recursive calls you will start understanding what pattern am I mentioning, or we will be coding that up in future. Okay, so let us take a very small array and let us have only as of now 3 integers, or 4 at max. 1, 2, 3 and 4. Okay, these all are the 4 numbers in our array. Now the main thing, we talked about something called as take and not take. Okay, so let's see how will we be approaching this whole array and generating all the possible subsequences. Okay, let us say hypothetically that there is an index variable. Okay, that index variable is nothing but, let's say, an iterator. This iterator is right here. The position of this iterator is 0. Okay, iterator ind, its position is 0th index as of now. Now let us see what this will do. Okay, it has just one job to append any element that is there on ind. So any recursive call that we will be doing, whatever number is currently present on our ind index, we will straight away add that number to the subsequent array. we will straight away add this number to the subsequent array. Okay. Now let us see how we will approach this. Okay. There should be a base case. So how should I say? Okay, let us not think of the base case right now. We will be thinking as and when we go forward. But right now the main motive is to generate all the possible subsequences. Okay. Now take and not take. Just remember these two words. Recursive calls, just keep that in mind. Take and not take, just keep these three things right in front of your head. Okay. Now see, two decisions to make: take and not take. Okay. Take the number that is on IND and append it to the array. Take the number that is there on IND and append it to the array. So there will be a temporary array that you will be maintaining with each recursive call. Okay. Let us name this as temp. At the very start, this will be empty. Getting what I said? Take the number that is on IND and append it to the array. Okay. So one we took. Let us mark this as blue. Okay. Go ahead. I'll just be moving a bit fast. Okay. 2, 3, 4. Take the number at IND, append it to the array, increment IND. Increment IND. Okay. Increment IND. IND was 0. Array was empty. I took the element into the array. I incremented IND. IND becomes 1. Temp has now the first element. So temp is currently containing 1. Done. No issues. Very good. Let us see the not take part. Don't take the element at IND. Don't take the element at IND. Just increment IND. Okay. Don't take the element at IND. Just increment the IND. 1 remains as it is. 2, 3, 4. Index becomes 1. Temp still remains empty as it is. Okay. Go down. Again, two decisions to make. Wow. Again, two decisions to make. Take and not take. Take the number that is on IND. Okay. 1, 2. And append the index. And temp contains 1 and 2. Okay. What did this say? Don't take the number at IND. Okay. Don't take the number at IND. 1. Sorry. One is blue. 1 is blue. My bad. Just a minute. 1 is blue because 1 is already taken. So take the number at this was taken. So don't take the number at IND. Just move ahead. Okay. As you wish. 3, 4. Not my problem. IND becomes 2. Temp remains as it is with just 1. That is clear. Okay. Now move ahead. This call can itself have a take and a not take. Okay. Take the number at IND. Take the number at IND. So 1, 2, 3, 4 and append the index. Add it to the temporary array and move ahead. Don't take the number at IND. Earlier it was 1, 2. Don't take 3. Move ahead. 4. IND 3. Temp remains as it is with just these elements. Okay. Now just move ahead with this call. Just let us move ahead with this call. It is going to finish. That is the reason I'm just moving ahead with this call. Don't take the number. Take the number at IND. Okay. So now okay. Increment the index. Append it to the array. Okay. Here also, don't take the number at IND. Just be with the array. Don't take the number and just increment the array. Just do this. Just do this part, and IND becomes 4. Temporary array remains as it is. It does not changes as the previous recursive call. 1, 2, 3. Okay. Now the thing to observe right here. And this will follow up. Matlab, we can go ahead with generating all of them, but I think you got my point. Did you just saw what happened? If you look this part, see right here, this whole part that you are seeing, are these not some of the subsequences in blue? Are these not some of the subsequences in blue? Yes, definitely they are. Getting my point? So whatever temp array was containing at any instant, are these not the subsequences? Yes, they are the subsequences. So what we got? 1. We got 1 comma 2. 1 was already there. We got 1 2 3. We got 1 2 3 4. Are these not the subsequences? And if you observe the pattern, you get every new subsequence right here. This part is a new subsequence. This part is a new subsequence. This again is a new subsequence, and this again is a new subsequence. Let us at very random, let us just recursively iterate in this, or in this array only. Okay, let us recursively iterate in this array, and let us see what this will bring us. So yeah, it also has 2 decisions to make at any instant: take and not take. Any moment these 2 decisions will prevail. Okay, if it said take, we were key bhai, take the index at 3, take the number what is at index 3, 0 1 2 3. Okay, so the array will become something like 1 2 3. So we avoided, and take something that is at 4, a possible subsequence. Okay, increment the IND to 4 and append it to the temporary array. That becomes 1 2 and 4, something new. And yeah, if you just see the not take part, then this is also a possible subsequence. We were having 1, we were having 2, we are not taking 3, neither we are taking 4, so this remains as it is, 4, and our index gets incremented 4, and the temporary array remains as it is with 1 comma 2. So if you see just now, what is the temporary array that we received? What is that temporary array? See this part. If I just zoom in, till now matlab we all have seen all of these recursive calls. Okay, so I can just highlight this. Give me a second, I'll just highlight. This is the recursive calls that we have seen up till now. More ahead here, and a bit more till here. Okay, these all are the recursive calls that we have seen as of now. And if you observe the temporary arrays that we have received up till now, so what were those temporary arrays? So temporary arrays were first one unique temporary arrays, 1 comma 2, this one right here. Then go ahead more left. 1, 2 and 3. Okay, go ahead, more left. 1, 2, 3, 4. Okay, this call returns. It comes here. Is this unique? No, this is just a call for this one as it is because it was a not take thing. Go ahead, return not take thing. 1, 2. Is this unique? No. Go to the left. Is this unique? Yeah, something unique was received here right now. Are you seeing the pattern? 1, 2 and 4 in all the take recursive calls, in all the take, because left side we are doing a take. In all those recursive calls we are seeing something unique is occurring because you're taking now. If it would have been a not take, obviously it would have followed some previous recursive arrays. Let's say previous to it there was an array that did a not take, 1, 2 did a not take. So at the very right, if this array goes to right and right, for this case, to the very right of not take, this will still remain empty. Getting my point? To the very right of not take, this man right here will still remain empty because it is empty. In the rightmost case, it will be empty in the rightmost case. Getting the point? So the point to consider here is that every new array will be generated whenever we do a take, and that will always be to the left if you are taking it to the left, to the right if you are taking any element to the right recursive call. That is it pretty much. So yeah, now base case decision is upon you at what moment you want to stop. In this case we will just write key if the index, whenever it reaches the end of array, then return, simply return. No need to see further, man. Just simply return it. Okay, this will be the base case as of now. You have, if you understood this whole recursive call, you just solved one problem and you just solved a follow-up problem for this. And what is that follow-up? Let us say at any moment you are having this array. Okay, you are having this array. With that recursive call, can you not maintain a sum variable? You can always maintain a sum variable. At this instant, some variable will contain 1. At this instant, some variable will contain 3. They are the total temporary array sum. At this instant, some variable will contain 6. At this instant, the sum variable will contain 3 only. Getting my point? At this instant, the sum variable will contain 6 plus 4, 10. At this instant, the sum variable will again be 6. You can maintain a sum variable at every instance. You can maintain a sum variable. No one has ever stopped you. If you can maintain a sum variable at every recursive call, then if I give you a question, a follow-up question, return me true if there exists a subsequent sum that is equals to k. Yes, I can. Anyways, I can. At any instant, I have the sum variable. I'll be summing up all the subsequent arrays. I'll be calculating their sum. If that is equals to any time k, I'll just return a true. So far, so good. Now, if I just twist this a little bit, return me all the subsequence of arrays that are having sum is equal to k, then also I can do it. So if the question says कि भाई return me all the possible subsequences that have sum equal to k, then also I can do it. I am calculating sum anyways. I am having my temporary array in every recursive call. I am maintaining this temporary array in every recursive call. If at any instant the sum equals to k, then I'll append this array to some of my answer 2D array, because that answer 2D array will be a vector of vector or a list of list, whatever you said, but that will contain number of vectors, that will contain vectors whose sum is equal to k. So that is the whole point. With just one logic of take and not take, you were not able to solve just two. I think you were able to solve 3 problems. First problem, generate all the subsequences. Second problem, return true if the subsequence has the sum, any subsequence has a sum equal to k. And third problem, return me all the possible subarrays that have sum equals to k. So yeah, that is, and this can vary. More permutations can come for this problem, but what you should be aware about is the take and not take approach. So this video is solely dedicated to this approach that we just studied. So I think the explanation was pretty much clear, and I think this was a very fantastic approach in the recursive videos that we will be seeing going ahead. That was it. Thank you and have a nice day.